your tests are trying to tell you something. Ooh la la. This is like, whew. So, what was I missing? 9 things, 9 design hints that you might have been missing until today. Several of them, I am 100% sure that you never thought of them. You will see. Now, there is an article that if you prefer to read, you can cross-reference afterwards. It's very dense, very hardcore, but if you want to get an overview of what we discussed there, there is code. There is code. Very simplistic code. I must apologize for writing the most simplistic examples I could ever come up with. Typically, these ideas I do during my training that it takes days to get to those ideas, but that's why I will show you the simplest possible code that could demonstrate the idea. All right, things can get extremely polemic, extremely complicated in practice. But just to do this overview in a single hour, right? So my name is Victor Rentea. I'm close to Ukraine, as most of the listeners probably. I'm a Java champion. I've been drinking Java. I've been working in Java for, what's that, 16, 17 years. And I'm doing trainings right now for a living, trainings and consultancy in different companies throughout the world. These are usually my topics: Spring, Hibernate, and functional programming with Java. Architecture, clean code, and unit testing is straight from unit testing is what we will be talking about today. So, domain-driven design, clean architecture, refactoring, these are the topics that I usually teach, that I teach every week. I also have some hardcore topics out there, performance, active programming, and secure coding for the Spartans out there, if you want. And I'm doing conferences and meetups like I am doing right now, helping Codecamp. Thanks a lot for inviting me. Now, I have a huge community that I want to invite you to join also, besides Codecamp, which is called Bucharest Software Craftsmanship Community. This is the easiest way to get there, and I'm trying to do stuff every month with that community of mine. And the event that I did, all English, all remote. We are one of the biggest communities in Romania, but we are speaking English, and we are forever remote. Clean code refactoring, simple design. This is what I focus this community on. 4,000 people having fun, having lots and lots of fun. Completely free. Come and join. You will see. Check out the events that were there. Good. Now, if you want to go more deep, I do company training. You could join a group gathered from different companies, or there are also I also have some video lessons, quite intense. If you want to know more, there is my website, and I'm also on the social media if you want. I'm usually announcing all my speaking engagement, all my events on my social channels. Good. Referring to an old Romanian saying, no comment for this. Romanians will understand what am I talking about here. 3, 2, 1. But let's do this. So, what is the agenda? Here it is. 9 things. Better signatures, better APIs for the methods, immutable objects, promoting them, command query separation principle, functional core imperative shell, separation by layers of abstraction, role-based design. Oh, yeah, what the heck is this? I mean, did you heard about all of this? Let's see. And there is code. Wherever you see the keyboard, there is code associated. First question, are you agile? Agile. Let's see. Romeo, I had something. Okay. I will answer this as soon as I can. Now, are you agile? When I answer this, when I ask this, the answer is usually ish. Agile-ish. Now, Agile comes with this concept of emergent architecture. Emergent architecture or emerging architecture. The idea that if you put features after features, at some point the design will emerge by itself. If you read in the ideology, in the philosophy of Agile, this is believed to happen. The problem that I see today is that this emergent architecture never emerges. It's hard. It has some really nice philosophy behind, allowing the features to pile up and then cleaning up, but you have to clean it up at some point. If you just patch and hack and quick fix and dirty hack different things, this is what you'll get, right? So under design might be the default in many teams today, because they are rushing and running to meet the deadlines and to deliver features. They never stop and reflect about their design. But there is a solution to that. Tests. If you write responsible tests, tests will give you a huge amount of design feedback. Those 9 things that you previewed are coming from tests. Tests are telling you these things, and tests might hint you on how to organize your complexity. Now, do you write tests? Normally, I would ask for a raise of hands, but do you write tests before the implementation? Bam. What's the point? If I ask, do you write tests? I don't know, maybe 50% people will say yes. When I ask, do you write tests before the implementation? Maybe 5% will raise, maybe 10%, depending, right? Now, what's the point? Yeah, I'm talking about test-driven development, about writing tests early in the implementation phase. Maybe not entirely before, like TDD officially clearly says, but what you get from tests, as I talked with the organizers before, is that not only you get more real coverage and then you get more courage to refactor, no, but you get more design feedback. And that's what I want to focus this talk on, the stuff that you learn by doing tests, by writing tests. So writing responsible tests will not only give you this design feedback, of course, you will listen to and you will apply it to your production code if you think it's useful, but it will also skyrocket your design skills. It will skyrocket your design skills if you write responsible unit tests. And when I mention unit tests, 99% of the time, people think of mocks. So let's talk about mocks just a second. Mocks make our tests. There are 3 main benefits from mocks. Mocks, right? Mocks help us, first of all, to get repeatable unit tests. Those that some tests that don't depend on the external systems, right? But there are alternatives, like writing stuff on an in-memory database or using test containers or wiremock. There are alternatives to make your tests not depending on any external system. They are maybe Dockerized or maybe in memory, but they are not depending on anything external. Mocks do make your tests much faster than if you would start stuff up, right? And mocks also allow us to keep our tests reasonably complex. Now, I'm still trying to get to lay out the main concepts. Mocks, besides allowing to have super fast tests and decoupled tests, they also allow us to build tests which are reasonably complex. Whenever you face a function which is extremely complex, and I will be talking about cyclomatic complexity, it is a measure of how complex a function is. Basically, it quantifies the number of independent execution paths through some code. Now, if you have 2 functions, f and g, and there are 5 ways to go through A. Let me experiment. One way is to not enter the for and not enter the if. The second way is to enter the for in loop once. And then the third way is to not enter the for but enter the if. And then again, another scenario would be to loop and then enter. There are 4 cyclomatic complexity for such a method with a for and an if, right? Now, if you have a function which has a certain number of paths, and that function is called another function, if you want to test the top level one, f, you will have to write not 5, not 6, not 11, but in the worst case 30 tests to experiment every single execution path. This is not reasonable. So if you want to write end-to-end tests that cover everything that you wrote, those tests will grow too many because you need all sorts of combination, and also too heavy. You will have to provide a huge amount of information here in order to test what f does together with what g did. So technically speaking, when you are facing cyclomatic complexity, when you look at a function and you see a lot of branches through it, and you would think like, oh my god, I need 7 tests. Right? That's a function that you might want to test in isolation from the other. And you could use mocks around it, right? Anyway. So, this talk is not easy, folks. So it's recorded, it will be published soon. If you miss something, there is an article in there, you can review it, right? So my point right from the start is that if the amount of complexity you are facing for a certain use case is decent, it requires, I don't know, 5, 10 tests to write. Maybe you can test the whole stuff end to end. That's my testing strategy usually. I first struggle to test everything end to end. If you avoid mocks altogether, you get the following benefit. If you would put a mock in here and you will test separate, the moment you refactor somehow A and B, the moment this arrow changes in any way, okay, the moment the interaction between A and B shifts somehow, I don't know, is broken into the function is broken into two. Anytime you change anything, anytime you refactor the interaction between A and B, those independent tests will break. And this is very frustrating and causes a lot of pain. So instead of that, what I'm trying to say, if the complexity, summing up whatever happens in these two classes, if the complexity is not that high, you could try to test both classes together as a cluster of objects, allowing you later to refactor the interaction between them without breaking tests. So black box testing, more black box testing if you want. But if you are facing high level of complexity and if you want to cover all the branches, you can't escape mocks. So this test, this talk is about, assumes that we have serious complexity, many branches to cover in our logic, right? And you know what's very fun from a philosophical point of view, that unit tests, testing carefully the code will intensify the design around that complex logic that you have. Whenever there is complex logic, you will have more design to do. Tests will point you to do more design. That's it. Let's start. First example, very, very simple example. And I promised code, so here it is. This is a very simple warm-up example. Here, if you have this class, precise, send sprint finished email. Just look at this class. Send sprint finished email. This method over here, this method, does what? Takes a project as a parameter, goes inside the project, gets the product owner email, and sends him an email. That's it. The only thing that happens that I get from the project is just the email of the product owner, nothing else, right? And here's my test over here, which checks that I've done everything correctly. Now, if you wrote the production like this, you might not have any hint about what's wrong. But if you start testing this logic, you will see in this test that you have, in order to call the production method, you have to create a project. Why? Because this is what you require inside. And you instantiate the project and you set the product owner email. 2 lines of code. For what? Because the method takes a project. But if you look closely, you will realize I'm not really using anything from the project than the email. So the immediate hint that tests will give you is to prefer to go for more. What's wrong here? I have an enter. An enter. Let's see. What was just a second? Somebody. I have an extra enter for some reason. Oh, I think I know what's wrong. /n. Let's have it green. So instead of creating a project, setting it a product owner email, the obvious alternative is to take directly the product owner email. So let's do this refactoring. String product owner email. All right. If you do that, and if you pass separately the email that you want to pass, okay, that will make it simpler. Okay, I will use here product owner email. You will not have to construct a project anymore. Look, if you just wait a second, IntelliJ will figure out this is not used, and I can delete it. I don't require a project, of course. Out. Still not right, but anyway, I'm just curious. It's the same. Why is it different? Anyway, I think it's from courage return. Yeah, I'm pretty sure. Just let's be fair. Is equal to normalizing in new lines. By the way, folks, I'm using the best testing framework available in Java. It's called AssertJ. Okay. So if you just pass the boss at MyCorp, you would not need to have a project at all. So these 2 lines disappear from the test. So writing tests will hint you about this idea. Let's take less complex objects as parameters, more primitive. Okay, the test is easier, and also the method is easier to understand. You just take a string as a parameter. So that's the point here. Instead of having a method taking a huge object, you have methods that take some parts, exactly the parts that you need inside. Okay, and tests will also get simpler, as we saw. I don't need to instantiate that complex object anymore. Good. And the point here is that the production gets easier, because whenever you see this function called, you will see directly what it requires. I only need the product owner email, nothing else. I don't need the whole project. So the production code gets to benefit from this. Good. Next idea, immutable objects. Now, look at this code. Method which sets some data. Let's see some code. All right. Good. By the way, the shortcuts are displayed over here. And by the way, if you are curious what the heck am I typing and how am I typing that fast, I have a video on my website together with JetBrains in which I explain what the hell am I doing when I'm typing. Okay. Now, this takes too long. Where is this code? From the test. Thank you. Good. So, caller, it's the production code. The production code goes to an object repository, finds something, okay, calls a method, another method, given it as a parameter, the object retrieves from the repository, right? And that other method, which is complex, remember I said I will assume complexity, many branches, ifs and fors and try-catches stuff, complexity. That method that I'm calling with the object, that method changes a field in the object. You could easily test this method, very easy. You just pass it an object, and you can assert afterwards that the x changed inside. It's not a problem testing this method. What becomes a problem is testing that method here, without calling the other one, because you tested that already, okay? You put on this like 4 or 5 tests, and you don't want the other function to be calling that, because you've already tested it, and you don't want to overlap your tests. So what do you do? You want to use mocks in order to block the call that goes from production code here into the method. How you do? It is like this. The problem is, just look carefully. Object is retrieved. Object is sent to a method that changes it. And afterwards, I use the change in production, you see? I use the change. I return whatever was changed by the method. This is a very bad practice to change the state of an argument. Changing the state of an argument is a bad idea. If you do, however, and if you want to cut out this call when you test the caller, what will happen is that you will have to use this terrible, weird syntax. What the hell is that? I'm programming a method call. This method here is intercepted, and whenever it is invoked, I'm running a callback. Why do I need to do that? Because I have to emulate, to fake this change to the parameter. And the only way possible to do it in Java and in any mocking framework is by providing a callback to the function. So I'm programming the mock to answer with if you might have heard of a thing named answer in Mockito. Callback. Very weird code. Very weird code. Now, the problem is that you are not following immutable objects. Let me play a bit. If you compute some value inside, and instead of changing an argument, which is a terrible practice, instead of doing this, it is far more polite to return the change. And let's see how this simplifies I will set object, yes, but not here. I will change the field, but not here inside my method. Instead, I will move the mutation out in my caller. You will see this idea again a bit later. So I will take this part, which effectively changes the state of the object, cut from here, paste here. And from the method that I had, I am now returning x. And x I use afterwards to change the state of my object outside. So do not change state of your arguments. Don't ever do that. Okay? Return the change. Return the change. Good. I think I'm doing this idea. I'm saying this thing, return the change, at least 5 times per week these days. In different trainings, different companies. This is a very, very, very interesting idea, return. How will this improve my test? Well, if you want to mock this method, if you want to program this method what to return, you wouldn't need that anymore. No. Instead of all that madness, I'm sure some of you never saw that kind of code. Instead of all that madness, I can just do when, and I can say when when b dot method, then b dot method, then return, then almost here I need to put an any, I think, any, thank you, then return, thank you, then return, just a second to start my air conditioning, but yes, my laptop overheats sometimes. Then return what? Stubbed. And I am returning the value. The test will still work, and it will be much simpler. I'm just programming what the method returns. I will not be changing parameters, all right? So, immutable objects, doing this is very bad. Mutating a parameter state often causes very awkward bugs and hard to trace things. So, what I changed the code to is into a function that returns whatever had to be assigned out, technically, right? And that simplified the test enormously. I mean, you could think of doing this change just to simplify the test, but it's a good idea to return what you computed instead of changing. So instead of this insane test, now the test is much easier to read. I mean, I've read 3 criminal lines and I only have 1 single line. Good. All right. Test is great. Perfect. Next, immutable object. Now, there is one very, very interesting principle out there. It was first introduced by Bertrand Meyer in 1994, command query separation. To understand the point, I must start with the basics. If you see a function returning void, the only reason why you would ever call that function is for it to change something. If that function returns void, why would you call it? To do stuff, to change stuff, to do side effects, as they are called, to change maybe a field, to put active to true, to send an email, to call an API, to do something, okay? So functions that return void, we expect them to be commands. So Bertrand Meyer said, functions should basically be split in 2 types, command and queries, but please don't think about database query over here. It's a concept, right? 1994. Command and query. A command does something. A query, on the other hand, returns result. And I want to ask you, if you see a search returning you a list, if you search the second time with the same criteria, would you expect to see different results? I'm not sure, probably not. One more thing, if you search something with some criteria, would you expect that somewhere in a database a row is inserted? You know why they inserted the row? To do the artificial intelligence machine learning business analytics on your searches to improve their business. I saw the commercial at the beginning. So the point is, search might insert stuff. And you might not expect that, you as the user. Compute price, if it returns you a second time you call it for the same flight, if it gives you a higher price, I'm pretty sure you will be angry about that. It's the same flight, why are you giving me a higher price, right? So compute price, when you see a function returning a value, you expect that that function doesn't change anything and returns the same results for the same parameters. In other words, you expect functions that return values to be pure. Pure functions, they are not allowed to do side effects. They don't change anything. Okay, not even a field, nothing. And pure functions are giving you the same result for the same input. If you give the same argument, it will give you the same results, okay? The simplest example for a pure function is a mathematical function, okay? If you want to have a close analogy, mathematical functions. So basically, command query separation means tries to say that functions should be of one of the 2 kinds, either query or commands. And here we are. By the way, this particular principle, this is the 3rd principle we are seeing. This principle is very, very deep. This is 100% you would try to follow it. Let's see. A method should be either a query or a command. Let's see. A query is a pure function returning data. A command has side effects and returns void. Let's see if I can convince you why we should strive for that. Now, this is the test that I'm writing. When dependency stuff then returns 7. What does this mean? It means that the tested code, let me open the tested code. Okay, the tested code will always be in the left side, the production code, and the test will be on the right side. So the production code over here calls stuff. Because it calls stuff, I had to do when then return. By the way, folks, I expect you know how to use mocks. Good morning, everyone knows to use mocks. Right? When dependency stuff then returns 7, so I am returning a 7, so that 7 is here, technically speaking, returned. Now, and then in the same test, you feel like adding also this verify. And you get to the conclusion that you have to put verify in place. And let's understand why. If you run this test as it is right now, why do we need the verify here? Let's see. When we write the code, calling stuff with this object does another bad thing that we saw previously. It takes the object and changes it, changes the argument, changes the state in the parameter, right? Changing that state in the parameter here has to happen a single time. Look, what would happen if I would call this function 3 times? If I would call that function 3 times, my test will fail. My test will fail because look what happens. The object that I create initially has x equal to 0. I pass object as an argument in here. 0 plus 5 equals 5. That's why I assert at the end that the object. Do I assert at the end? I don't. So technically, I need to call stuff just once because stuff changes the state somewhere. Because stuff changes things. Stuff is a command because it changes stuff. But stuff is also a query. Why? Because it returns stuff. So this function violates command query separation because it changes and returns. When you change, you don't return. That would be simplified to say it in a simple way. Now, if you think of putting verify, you might want to put that because you want to guarantee that stuff is called only once. Because if you call it 3 times, that will lead to incrementing too many times the total. You will get 15 at the end if you look in the object. So you want to make sure it happens a single time. So you put verify and you put here query. This idea to when then return a method and then the same method to verify, that is a bad practice. So if you need to both stub and verify the same method, you are breaking command query separation. Bang. So when, then, and then you verify the same method, that method returns the result as proven by the fact that you say then return. And it also does side effects because you need to check that those side effects had happened once, right? Now, what would be the redesign that you could do? You could say, I copied the method and I said separating them. So let's say increment total. Super simple example. I apologize. Not realistic example. Super simple one. Okay, just to prove the idea. This is now a command. The other one is now a query. Okay, that's it. Technically, I don't even need to have to take this as a parameter. So instead of calling one single method, command query separation might hint you should consider this idea to run the command and then run the query. Okay. If you do that, you won't be stubbing and verifying the same method. Here, you will stub the query, and then at the end, you will verify the command. And this is the idea. This is not a new idea, folks. This is back from what, 2000, and Martin Fowler wrote about this many years ago. The mocks aren't stubs. You should not be doing both. So what's that? 15 years ago? Okay. So mocks aren't stubs. The moment you see stubbing and verifying this method, that is a design hint that you might want to look into breaking this method into two. It might be doing too many things. It might be violating the single responsibility principle. It draws your attention on it. Okay. So it's still compiling. Just a second. And the test is hopefully green. Is it green? 3, 2, 1. Come on, it's a demo. It's green. Thank you. Good. So there is one exception to this rule. The moment you are calling out, if God calls outside, perhaps you are bringing some data from an external system using some REST call. Now that call might cost you money or might take time, and you want to make sure that it doesn't happen twice. If that's the case, it's a reasonable excuse. It's a reasonable. It makes sense to verify because it would guarantee that you only call it once, right? Or if something very critical happens in the outside system when you call. So if it's an external call, it's quite a. It could be desired to do that. But if you are talking about a function which is internal to your application, something in your core domain, that should not happen, ideally. So, okay, that this is the nuances. 4 now. Complex logic requires many tests. Duh. I mean, yeah, I need to go through all the paths. Good. But then if testing that complex logic requires you to when, then verify, and you have to write 7 of these tests, then you will do something like, you won't survive writing 7 tests, repeating that kind of madness. So, what's the point here? Whenever you want to write many tests, you should think in shrinking, reducing the size of those tests. What do I mean by that? Reducing the use of mocks. What do you mean? You should not be playing a lot with mocks if you want to write many tests on a method. I need to demonstrate because this is very big. This is very big. Look. Let's see the tested code. And as usual, the production code is in the left side, the test is on the right side. Case 51. Case 51, I call it here with 2 IDs. The first thing it does, like most of our use cases do, when it starts, it loads stuff from database by ID. And then it goes into some very complex logic that you will have to test using 7 or more tests. So technically speaking, you will have to write such tests, 7 of them. Ouch! Why is it bad? Because look, because you load from the database. You use a dependency. Because you use this dependency, you have to say when then, to bring the data from the repository, to decouple the database because you want to write many tests. Good. Then what? At the end, you do save. Because you do save and you want to see what was put in this C, you need to use captors. Oh my god, this is so ugly. Captor. Very strange things to be able to get a hold of this argument, right, from production code. Extremely strange. Very ugly. So what am I suggesting here? This is a very deep, very useful idea. I want you to take this part, which is very complex, extract it alone, the complexity that happens here, into a pure function. Why is it a pure function? Because it doesn't use any other external dependency. Based on the inputs, it does the logic and returns some stuff. It does not use any dependency of its own. And then this pure function, move it in a separate class, in what we call a functional core. So here we are, folks. We came from an imperative shell. What does that mean? Calling, right? Do that, do stuff using the dependencies. And then we isolated the big complexity into a pure function which resides in a functional core. Now, if you do that, the test that you could write on the functional core, let me try to sketch it fast. Something like this, yes. I want to instantiate my functional core, maybe target or core equals new. You do that, and then if you want to call the function, you would not need to when then anything. You will just have to pass a as a parameter. All right? You will reduce basically the use of mocks, pure function, by passing. And here I did it for lines. Pure function. Let me check one thing. Functional core, pure function. What's wrong? It's still compiling probably. Okay. And then this pure function returns me C. Come on. What's wrong? Functional core, pure function. Come on, IntelliJ. I'm literally thermal throttling my processor right now, so I hope it will wake up. Oh, test. It's quite stupid. And then this is C. This gives me C. And C has data inside. Then just compare the tests. Okay. And now the test below, it's very comfortable to make 7 of them. There is no issue with that. Okay. There is no problem because it is so small. So this is the point here. It's a redesign isolating pure functions which take arguments and return results. Keep your most complex logic in pure function. So the heavier some logic is, the less dependencies it should have. This is a very deep design principle. It's called functional core imperative shell segregation. I first learned from this from Venkat Subramaniam. Functional core imperative shell. It means that whenever you have a chunk of complexity, whenever you have a lot of stuff to write, a lot of logic to test, that logic should be isolated inside the functional core, should be pulled inside pure functions. And then any kind of dependency you have, through which you bring data or through which you do side effects, any kind of dependency, you push it out of that core. Like I did, I basically extracted the pure function out of that stuff. And the original code, which does the interaction with the dependencies, remains what we call an imperative shell. Now, there is a very interesting thing that happens next. Since the complexity moved away from this method, testing this is trivial. Yeah, I would still have to use mocks, but I wouldn't have to write 7 of these tests, right? 1 or 2 will be enough. Where the complex logic moved to another function that I can test with very simple, straight tests without any mocks, 0 mocks, okay? So that's the point here. Functional core imperative shell segregation. Okay, so design the most complex parts of your logic as pure functions. Okay, they are easier to understand, easier to test. What's the number of this? 4 or 5? I think I'm done with that. There will be a recap, don't worry. One more thing. Another design. You have 2 complex functions in the same class. Complex, very important. 2 complex functions. F is complex, G is complex. And they call each other. Boom. Now, if G is complex, it deserves dedicated tests. And you put tests on G separately. Good. 7 tests here. But then you will have to put 7 tests there. If you have to put a lot of tests there, something funny would happen. If from F you call G, G was already tested, right? Walking through G again might lead to strange situations. So you might want to block the call from F to G. I know it sounds a bit weird, so let me show you the code. Here. This kind of stuff usually happens when we are facing with some God class, as they are usually referred to, classes of, I don't know, thousands of lines of code. There is a function in here which calls another function, and they are both complex. Okay, both complex. You test low, you have serious tests firing on low. You can imagine many tests, not only this, okay? You just imagine many tests on low. Good. Now, you want to test high, this one. You test high, and what happens? Look, if you don't do anything, and if you just call high from the test, if you call high, just look, I'm trying to test this if. What does this if say? If the order payment method is card, then return bonus. Good. So I am creating an order with payment method equals card, and I am asserting at the end that I get bonus out. Okay? Actually, reasonable test. Perfectly reasonable test. The problem is that in production, the method high calls low. And because it calls low, it fails with null pointer exception from this dot, technically this dot. Why? Because in this low method, order is checked. When was it created? If it's created more than a year ago, it throws an exception. So I get now a null pointer exception from this method into my test here. Not fair, because low was tested separately. It is complex and it had its own dedicated tests. And this is the feeling. You will start being annoying that the production code that you're testing calls another local function which was already heavily tested. Whenever this happens, you Google and you find a hack out of it. That hack is called spies. Spies, or partial mocks as they are sometimes referred to. This partial mocks means that you can have in the same class that you're testing in, you can have functions that you're targeting and other functions which will be mocked away. So technically what I'm doing over here is it's saying that whenever low is called, do nothing. What the heck? Why? Basically, I am blocking the call that happens from above into low. I'm blocking this call, saying don't go there because I will get exception in it. I don't want to go into low because low was tested separately. Boom, surprise. Now, this is called SPY. If you just read into the documentation of SPY, there are pages here saying that you should not be using it very, very often. If you read just a bit more, you will find that SPYs are completely forbidden in good design. Completely forbidden in good design. SPYs are a clear sign that you are violating, that technically, whenever we are facing this situation, the best thing you could do is to take G out in a separate class. What? What do you mean? Let me demonstrate. So if you have SPYs right now, this is I think the only design principle that I will tell you, that if you are now violating this with your project, go ahead today, tomorrow, and change it. When you have a SPY, it means that you have complexity there, which delegates to further heavy complexity in another function. What should you do in this case? You should break the class into two layers. What do I mean by that? I mean that, look, class, low level. The principle that the partial mocks try to hint you about is called separation by layers of abstraction. Separation by layers of abstraction means that whenever you have something heavy, you need to design abstractions, simplifications to clearly separate parts of the code on top of which you build further. So technically speaking, I know it sounds, look, what I will do, I will put it here, and then now I will have to depend from God to this low level. Now I moved the code into another class, right? And I moved the class and I moved the code into another class because if both are complex, they both deserve their own house, their own place. So what's the idea? Heavy complexity calling more heavy complexity needs to be cut between, separated into things. What would that mean? It means that here you don't need really a SPY. You will write a test for low level. Let me try to write that. Let's see how hard it is for it to be generated. Create a new test. Can I do that? Let's see. Okay, and then I move it to the right side. I need to move here the test that had to do with low in this. So I will technically have to break the test a bit, right? Low, dot low, and actually to, you know what? Let's, for simplicity, because time is precious, let's do that. I've tested it technically. And now in the other test class over here, do not use SPYs. Instead, move to classic inject mocks and at mock low level low. Now this low over here, if you want it to do nothing, it just has to do absolutely nothing because Mockito by default doesn't do anything. Done. Okay, so clearly separating. Now this principle separation by layers of abstraction has a very fancy name. It technically tries to say that complexity needs to be cut in between if there is some stuff that depends on more heavy stuff. Clearly separating stuff, clearly separating what low-level logic versus high-level logic. So we have now high-level logic here, depending on another class that contains logic. So, green, good. All right. What we did: better signatures, immutable objects, command query separation, functional core separation by layers of abstraction. Congratulations. Now, another thing: two complex functions in the same class. Two complex functions in the same class. Let me show you the code. It's easier if you see the code. And now it's a marathon. It's all recorded, and you can watch it again. Two complex functions in the same class. What am I looking for? Kebab. Is it? Yes. This one. All right. Okay, kebab. Yoo-hoo. Good. So here you go. Shawarma, if you want. Kebab has two complex functions. Now, compared to the previous one example, these two functions don't call each other. No, but they just happen to be in the same class. The two complex functions use, because they are complex, they require many tests. And you could imagine a lot of tests, both on complex 1, both on complex 2. Both are requiring a lot of tests. Many tests, yeah? So just imagine, many tests, okay? Many tests. Just let's play the game for a second. Okay, let's make more of them. Let's see how it feels. 1, 2, 3, 4, 5. And then you will wonder, wait a second, every single time I am stubbing the is cucumber allowed. You know, in kebab you can put cucumber if you want, in some shawarmas. When dependency is cucumber allowed, then return true. Why are you doing this? Because if you weren't allowed to put cucumber, you will get an exception. Okay, so you have every time to set it to true, because otherwise you get an exception. Ouch. So, and you have to repeat it 5 times. Don't repeat your self principle, dry principle will tell you not to do that. And the typical workaround is to create a before and to move the when into this before. I think I had already a before. Yes, thank you. To move it into the before, because it's common to all of those 5 tests, which would allow you to destroy this repetition. Okay, just sketching a bit. And I want to show you what happens next. So I've tested this many times, every time going to, not falling into the exception. But what happens if you want to test the other function the same way? I will tell you, you can anticipate. I will copy paste this test many times, and then I will say, look, repetition, of course repetition. It has a similar thing, but with onion. Any good shawarma should have onion. I mean, how can you bake a shawarma without onion? So this is onion allowed should also go in the before. Now, what happens? I've put stuff which was common to these tests next to stuff which was common to these tests. I've put them in the same before, in the same class. I might get away with this, but then tomorrow one test here will break, boom. I will go and look at the before and I will wonder what part of this before is mine and what part of this before is others. And I will have to figure out that this is my part. Again, it's a super simplified example, but I hope you get the point. Putting stubbing shared by different sets of tests in the same test class will lead to what we call fixture creep. Fixture creep. The before grows enormously to contain common stuff for any tests in the class. Now, I used myself to do that 10 years ago. No problem. No problem. No problem. But 3 years ago, Mockito changed. And it doesn't allow you to do that anymore. And here's the famous unnecessary stubbing exception. Mockito changed at some point, causing panic in developers when they upgraded Mockito versions. Mockito now fails for such situations. If it sees you stubbing some method, but not using the stub, just think of it. It runs complex 2. Complex 2, when it runs, it executes this code. But then at the end it wonders, wait a second, I never saw you asking for onion. So technically Mockito at the end will check that all your stubbings were actually used. If you want to skip one of them, there is a workaround for that. If you want one of them to be optional. But you know what developers did when they migrated to the Mockito version? They went here and said Mockito settings, strictness equals lenient. After which it all went back to normal. But poor fellows in Mockito, they didn't do this change for nothing. They were trying to tell you something. The library authors, the authors of the library, which is the most used library for mocking in Java today, copy-pasted, replicated in many languages, they were trying to tell you something, that it's a bad thing to accumulate all the stubbings acquired by anyone in a shared before. This is bad, right? So the code example is clear, so maybe don't look here. The point is, in the before each, when you start accumulating when, we call this fixture creep because it accumulates stuff for everyone, right? A bloated fixture that will make it hard to trace later when one test fails and you want to figure out why, you will have a very hard time. because you have to detect which are yours, which are others. Very, very tricky. Now, the typical recommendation in such cases is to break the class. What does that mean? It means that you want to make, not lenient, that's a bad idea, but instead, look, break the class right here. Make two tests. One is for kebab test complex 1. The other is for kebab test complex 2. What do you mean? I mean, you break the class because the fixture is not clear, is fuzzy, is creeping out. So here you are. This complex 2 only uses cucumbers, perfect. The other one only uses onions, very good. Break the test class into. Actually, Sandro Mancuso has a very interesting naming convention. Maybe I should point you. I don't have the link prepared, honestly. Never mind. So the point is the before should be specific to all the tests, used by all the tests in here, okay? Test passed. All right. That was my point here. So break the complex test. But you know what you can then think? If you look at tests being broken down, you will wonder, wait a second. And you break the production code. What? What's this? You break the production code because you realize that there is high complexity in here and high complexity in here which were not related to each other. So you break it in two pieces. You get loosely coupled design, you get better, clear, sharper code in production code. Coming from tests, I did it myself several times. I realized I was breaking the test classes because they grew so big. And then we stopped and we said, wait a second, what the heck are we doing? Let's break also the production because that's also very complex. Pretty big. So break unrelated complexity for clarity and for loosely coupling. You don't want deep complexity to be sitting in the same class if they don't have anything to do with each other. Nice. Okay, two more which I won't show code for. I will just explain the point and I will let you read more. This one comes from the inventors of mocks. Can you imagine that? The ones that actually laid out the ground for mocking in 2004. The authors of JMock. The first people actually using mocks. They said wrong topic. Let me retract. Let me tell you in another way. I see today in many teams a terrible habit. You finish the implementation and then you write your tests. To write the tests after you finished the implementation, you will copy paste all the dependencies you had. I don't know, copy paste all the dependencies you had, Control C, Control V. You put everywhere at mock and you start unit testing. This is what I see many developers doing. And it's normal at the beginning of your career. After you finish the implementation, to test by copy pasting all dependencies. And then 2 years later, they come to me and they say, oh, Victor, my tests are fragile. Every time I refactor something, things break. And the tests slow me down. I have many teams telling me this. Teams that were testing for many years and they had hundreds, thousands of tests in a project. Tests are slowing us down. What to do? The problem which the authors of JMock pointed out is that you should not be blindly mocking dependencies. You should instead mock roles, well-defined, single responsibility roles. So before mocking a dependency, before copy-pasting dependencies, think a bit. Is the role clearly defined? Is it sharp? Does it have a meaning? Do I want to depend on that thing? So do not just blindly, and ideally write tests earlier to get this kind of feedback earlier. I'm not that religious guy that says TDD, you either TDD or otherwise you're stupid. No, I won't say this. This is wrong. TDD is not a religion. TDD is a mindset. If you write the tests earlier, okay, you could implement this rule. You can say no test can get to remote, to master, except if it has tests. It's clear. If you want to play around in your local, okay, but at the moment you put code on the in the shared Git, it should have tests. So that will force you to write tests earlier, and tests earlier will get you this feedback earlier, which is very good. I promise. These three last, I want to actually demonstrate in code. If you can help me, folks, the organizers, I have to finish at sharp, right? At 4 sharp.
We can finish like in 1 minute because we will
1 minute.
have our next guest in the
Ouch!
lobby.
Ouch!
I was
You
afraid that you wanted me to help with the
no!
testing part.
Ouch! Just a second. So
I wish
I should finish in
wasn't
1 minute. All right. All
worried.
right. All right. Then I will leave this for another time. Let me just do the recap. The recap. The recap. So these three, it didn't fit. Sorry. It was the first run for this talk. Sorry. More calls from when you call. If you write tests, heavy tests on your production code, you will call those functions more, and you will get more feedback about how well the signatures are, and you will get better skills yourself if you write tests earlier. Immutable objects rock. Tests will also tell you that. If you have a function, don't do when then on it, and then verify. That means you're breaking command query operation. Think about breaking the function in two. If you have to write more tests, then you should make less use of mocks, which means that you should isolate complexity into a functional core, pushing outside the imperative, the interaction with the outside world. Partial mocks, aka spy, are a bad thing. I will crash every code review I see with this. I will tell you, think about breaking the class in two. Bloated fixture, I just demonstrated that, putting too many things in the before. You should break unrelated complexity. Mock roles, not objects. There were two more, which pointed to the onion architecture and to an object model pattern, but they didn't fit. Technically, that's it. I actually don't have a closing slide, so let me go to the first one. It was recorded. There is an article. Yes, we will continue this in a meetup. I will schedule an event right today on my community to spend more than an hour. But thank you very much, Codecamp, for.
Thank you, Victor. Thank you, Victor. I think it's not enough time to
I have to tune the
testing
content.
and automation
Yeah.
and yeah.
I'll,
But this gives us the opportunity
yes.
to get you acquainted with our next featured guest, right?
Hello. Oh
Mark
my god. Oh my god.
and Milford. So Mark Richards and Milford. Welcome at Codecamp, guys.
The gods are here. The gods are here. Oh my
So
god.
Victor is one of the most active members of the Codecamp community, and in general, one of the most active and yeah, energetic and positive person that we know. So I'm glad that well, we had this like 10 seconds to
Yeah, I must say I'm really honored to meet you folks. Never actually met in person, but amazing job you've done. Amazing job. I'm reading heavily from what you're publishing. So, oh my God,
well, thank you
amazing
so
job.
much, Victor. And I love the chainsaw. That was really good.
Yes, yes.
And
Yes,
Victor, we're looking forward to having you at Codecamp next time. Maybe to continue this conversation. That flame that a while ago came up in the industry. TDD is dead. No, it's not dead. And the whole
Oh,
conversation.
that's an amazing podcast to listen to. Yes, yes, yes.
Yeah, maybe we'll have a similar conversation sometime soon at Codecamp. Why not?
Wow.
Until then, all the best. Good luck.
Yes.
Bye.